Good day, everyone. As we discussed in our previous lecture on the safety features you have to follow while charging the battery, it is also important to consider a good charger for charging the batteries. For that, we have to properly select a charger for our battery. In our current lecture, we will look at the selection criteria for selecting a charger for our battery. We will also look at how do we select a power distribution board for our drone also. Let's look at it in detail in our upcoming slides. The drone battery charger we use is a smart piece of technology. Using microprocessor control circuitry, this drone battery charger monitors the conditions of the battery to vary voltage and current throughout the charge to optimize charging and prevent damage to the LiPo battery. Most modern drone battery chargers are capable of charging at a variety of different voltages. Google batteries, for example, may require 8.4 volts, while the drone batteries may require 16.8 volts and above. Drone battery chargers should very easily be able to charge at a variety of user selectable voltages. That way, a drone pilot can use a single charger for all his batteries, from the radio transmitter battery, video receiver battery, toggle battery, and the batteries for many different types of drones. For drone battery safety, it is crucial that the batteries occasionally have the individual cells balanced, meaning that the charger will adjust up or down the voltage of each cell in a battery so that they match. Modern battery chargers will have balanced ports so that the individual cells of a battery pack can be balanced, while of variable use to the drone enthusiast. Most battery chargers on the market are capable of charging multiple types of batteries in addition to the LiPo. For example, most chargers are also capable of charging lead acid batteries, like what is in your cars, or nickel cadmium batteries for other uses. The control circuitry can adjust the voltage and the charge rate, along with the total charge applied to a battery. This makes battery chargers useful tools around the home workbench as well. Nobody likes to wait for the batteries to charge while their friends are flying without them. This can be prevented by having a large number of batteries or by having a battery charger that can do two things: charge in the field and charge multiple batteries at the same time. Today's battery chargers can often utilize many sources of input from power, from alternating current in your home to the direct current provided by a car battery or other larger battery. Furthermore, it is important to note whether your battery charger has a built-in AC-DC converter so that it may be plugged in to your wall outlet at home directly. Without it, some battery chargers require an external AC-DC converter. Many battery chargers have multiple outputs so that they may separately charge multiple batteries at the same time at different voltages and at different charge rates if need be. Using a battery charger with the ability to utilize DC input, which also has multiple output, allows pilots to charge multiple batteries in the field. This can be a great advantage when the race is held off the beating path or there are no available outlets. It is also cost effective as you don't have to buy as many batteries to enjoy a full day of flying. When buying a LiPo battery charger, it would be easier if you could just walk into a hobby shop and ask the staff what charger you should get. However, if you are getting it online, you are pretty much on your own. Therefore, researching beforehand, knowing what you need and what options are available is very important. There are various criteria for selecting a battery charger. The various selection criteria are as follows. First, a programmable charger, charge current, charger power output, support for batteries, and multiple cells. There are non-programmable chargers which are plug and charge. You just need to plug your battery into this charger and it will start charging. No input from the user is needed. This might seem simple and economical too, but they are very slow in charging and you can't change any of the settings and options. High quality chargers nowadays are almost all computerized and programmable. A programmable charger allows you to set all sorts of parameters such as charging current, types of batteries, charging periods, etc. They show you the battery condition, such as what the voltage is in each cell, how much current has been charged into them, and so on. It basically manages the charging for you in a way you want, ensuring the batteries are charged safely and accurately. Some of the programmable chargers also do some clever things, including adjusting charging current depending on a charger temperature, auto detecting battery cell counts, and battery voltage level. You can even discharge your battery for storage with some programmable chargers. For safety, LiPo batteries are often recommended to be charged at no more than 1C, although some expensive LiPo batteries are advertised to be fast charging capable, which can be charged at 2C or even higher. If your batteries aren't very good and you charge too fast, they could overheat. To charge at 1C means you are charging at the rate of its capacity. For example, if you have a 3S 2000 milliamp hour LiPo battery, the charge current would be 1C into 2000 milliamp hour is equal to 2000 milliamp hour, which is 2 amperes. To charge at 2C, the charge current would be double, which is 4 amperes. Every charger has a power rating and a maximum charging current rating. The maximum charging current a charger can provide is limited by these ratings, whichever limit is reached first. LiPo charger power is measured in watt, which is calculated by multiplying the voltage and the current. If your charger does not meet the power requirement, you might find it difficult to charge your battery at lower current. To work out how much power you need in a charger, you can simply multiply the charging voltage and the current. For example, to charge a 3S 2000 milliamp hour LiPo at 12.6 volts at 1C, you will need a charger that are rated for 25.2 watts or higher. So it's clear that if you want to charge at 2C, you will need double of the power to 50.44 watts. Note that when dealing with different cell count LiPo, the max charge current also varies, but it should not exceed the max charge rate of your LiPo charger. For example, for a 50-watt charger that has a rated 5 ampere max charge current, you will find the actual max charge current for 3S battery to be only around 4 ampere. But for a 2S battery, the calculated result is now nearly 6 amperes. But you wouldn't be able to charge at 6 amperes because the charger is rated at maximum 5 amperes. This is so far only an estimation. There is also an efficiency loss, so you definitely need higher wattage than the number from your calculation. It is safe to assume a power loss of around 20%. So if you're looking at a 50 watt, a 60-watt charger would be a good choice. For mini quads, we need is LiPo support. But it's also good to have HVLI support. It would be a bonus to have nickel NIMH support too, which is useful to rescue overcharged LiPo that cannot be recognized by the charger. Some chargers might support other types of batteries too, including nickel cadmium and PB, which might not be that useful for people who only use it for flying multi-rotors. Most low power chargers are single channel chargers. Multiple channel chargers are very powerful. Basically, each channel can be used as a small charger. For example, with a 4 channel charger, you can charge up to 4 completely different batteries at the same time, regardless capacity, voltage level, cell count, almost like you're charging them on a separate charger. They are great as you won't need a parallel board to charge multiple batteries, and you can set different settings for each channel, such as charge current, which makes it really handy. The power of multiple channel chargers is normally the sum of all channels. Some of the top drone battery chargers are as follows, which is Venom Pro Quad, Amin Hobbies Prodigy 610 Quad, Dynamite Passport Ultra Force Duo, Electrify AC/DC Triton 2 EQ, Copper Polaron AC/DC charger, and high-tech RCD Power Peak charging station. There are much more than that are present there are much more than that are present in the Indian market. Do explore the good chargers that are present in the market. A power distribution board, also known as the PDB, is an overlooked component simply because it is outdated. Electronic components have come a long way in the past decade. Back in the days, PDBs were an essential component in building of a drone. PDBs essentially distribute the power from battery to the drone's ESC. But the technology has improved so much in recent days that PDBs also distribute power to some other peripherals like video transmitters, cameras, and flight controllers itself. Some modern flight controllers have integrated PDBs, are limited by space, and can only accommodate so much that do not do a very good job at filtering the voltage spikes from the insane current draws from your quads. Having said that, the PDB are still preferred by some people, including myself, as they reduce the stress on a flight controller and are usually better filtered from electrical noise. There are various factors too governing the selection of the PDB. The factors are as follows: voltage regulator, voltage and current capability, PDB with VTX, and current sensor. Let's look at these factors in much more detail. PDBs have come a long way from just bare bone PCBs that distributed currently to so much more. And one of the nicest advantage is the integration of voltage regulators. The lower filtration and build quality of the voltage regulators present on an FC might in part be due to the more advanced features being added to the flight controllers. The flight controllers are not growing in size, and cramming a lot of features becomes a problem that the manufacturers start to cut corners. The flight controllers nowadays are well optimized and usually have voltage regulators built in to provide power for other peripherals. The voltage regulators present on an FC are what's known as a linear voltage regulator, which are very inefficient and are cheaper. The PDBs have well switching voltage regulators, are most efficient, and do not emit excessive heat, meaning to say that the voltage regulators are well made when compared to the voltage regulators present on an FC. PDBs come in all shapes and sizes, all the way from 3-inch small quads to larger X-class quads. As the size of the quad increases, so does the voltage and current requirements. The smallest available PDB from Lumiere has a maximum current capacity of 100 amps and a voltage support for from 3 to 5. A medium-sized PDB from Maytech can handle a maximum current of 180 amperes, and larger size quads require voltages greater than 6S. And some of the available options on the market are one from Matic X class and raised quads. Both the PDBs support voltages up to 12S with a maximum current of the RDQ at 500 amperes. So it all boils down to the size of the quad. If the quad is 3 inches or 4 inches, then a small PDB will suffice. Quads which are anything larger will require a medium power PDB, and which are much more bigger, which will require an X class. One of the simplest PDB combos would be the PDB and the VTX combo. Matix launched the FC Hub VTX with its first PDB coming with the VTX. This was the first of it and was hugely popular when it launched. It took the drone community by storm, with the HUB being the first of its kind. It saves an extra stack in the already cramped frames, and these boards perform on the tasks of two individual components. The VTX present on the SCB. HUB is no slouch, as it is one of the best performing VTX on the market. It is a 40 channel switchable video power supply of 25, 200, and 500 milliwatt. It also has a 184 ampere current sensor in case the flight controller is missing it. If you are planning to use a Matic or similar, then the PDB and the flight controller can be connected with a 30-pin ribbon cable, getting rid of the messy cables running between the FCs and the PDBs. Some FCs come with a current sensor, some don't. Current sensors have become so important in today's drone building. Current sensors, will help you to measure the amount of current the quad draws. 22-axis motors draw more than 30 amperes per motor, and manufacturers sometimes don't provide the most accurate of the current draws or the motors. Hence, for this reason, current sensing becomes essential to monitor the current draws of motors to ensure that the PDB is not stressed and not stressing the batteries. To summarize, we looked at the following in our today's lecture about drone battery charger, balance charging, field charging, selection criteria for battery chargers, some types of battery chargers, and selection criteria for PDB. One of the parts that is often seen now in drone companies is developing their own sets of batteries by connecting cells in series and parallel. This is something I have frequently seen while purchasing drones and batteries from different companies. Many times, the batteries are connected in series and parallel to get more voltage or current. Let us look at them in detail in our next lecture. Thank you very much.